I think the biggest lie we tell ourselves in AV is that the cable doesn't matter.
Oh, for sure.
We'll buy these incredible 4K screens, right?
Yeah.
Huge projectors. And then you realize the computer running the whole show is like 3 rooms away.
And your standard HDMI cable just gives up?
It gives up completely. 15, maybe 20 feet, and you're done.
Yeah.
Flickering, signal drop.
Or just nothing. It's a physics problem, really.
Exactly. So today, that's what we're diving into. We're looking at the solution to that exact headache, the Kramer TP-583RxR. Now, on the box, it just says 4K HDR HDMI receiver. But when you get into the specs, it's all about this technology, HDBaseT.
Right.
So our mission today is to figure out how this little box pushes, just a massive amount of video, audio, and control data over a standard copper wire without it all turning to mush.
It's some seriously impressive engineering. The whole promise here is distance. You're not just, adding a few extra feet. You're trying to cross entire buildings.
Okay, so let's start there. I was looking at the range numbers in the datasheet, and they seem to be all over the place. It claims it can hit 200 meters. That's, over 650 feet.
It is.
Is that a real-world number, or is that like in a perfect lab with no interference?
No, it's real, but there's a pretty big catch. That 650-foot number, that's for 1080p standard HD.
Ah, okay.
When you're pushing that relatively lower amount of data, yeah, it can pull that signal across the length of 2 football fields of copper cable. No problem.
But let's be honest, no one's buying a high-end receiver like this just to watch 1080p anymore. We're all in on 4K. So what happens when you crank the resolution up?
The range drops. It has to. The data density just skyrockets and physics takes over. But even at the very top end, we're talking 4K at 60 hertz with 4.4.4 color.
Okay, hang on. 4.4.4. We see that everywhere. For anyone listening, that's basically just the level of color detail, right? No compression on the color.
Exactly. It's full fidelity, pure, uncompressed color information. And that just eats up bandwidth.
So at full 4.4.4, what's the distance?
You still get 100 meters, which is 330 feet. Still very impressive.
And what if you compromise a little on that color?
Yeah.
If you go to, say, 4.2.0.
Right, where you're shaving off a tiny bit of color data that the human eye really can't notice anyway.
Yeah.
Then you get a huge chunk of your distance back. The TP-583RxR jumps right back up to 180 meters, almost 600 feet.
Okay, so there's a trade-off. But speaking of trade-offs, let's talk quality.
Yeah.
Usually when you're shoving a 4K signal 300 feet down a copper wire, you expect issues, lag, artifacts, that blocky look. Kramer's big claim here is that it's visually lossless. I'm always a little skeptical of that phrase.
And you should be. But what it's doing is using something they call intelligent compression handling.
Ah, so it is compressed. I knew it.
It is, but it's a very low-level compression. It's just removing redundancy from the signal in a way your eye physically cannot perceive. And it does it with almost zero latency.
Okay.
But the intelligent part is actually the coolest feature. The receiver is constantly talking to the transmitter at the other end. And if it detects a standard, older HD-based device that doesn't use compression, it automatically turns its own compression off to match.
Wow. So it dumbs itself down so it doesn't break the chain.
Or adapts to be a bit more polite. It guarantees that backward compatibility so you don't get a dark screen just because you've got mismatched gear.
That's actually really smart.
Right.
Now, in a big venue, it's not just about the video. You need to control things. Does this handle that, or am I running separate cables?
Nope, no separate cables. That's the whole beauty of HDBaseT. It's a bidirectional pipe. It carries RS-232 and infrared extension.
Which means I can sit in the control room and, turn the projector on and off remotely, change inputs.
Exactly. The data flows both ways. And for the audiophiles out there, it's not stripping out the sound either. It supports up to 32 channels of uncompressed digital stereo.
So your Dolby True HD, DTS to HD, all that just passes right through.
All of it.
There was one last little detail that I noticed, the physical box itself. The DigiTools enclosure. It's fanless.
Which is critical.
Why? Is it just about noise?
Noise is part of it, but it's also about maintenance. This thing is designed for dropped ceiling mounting. You're supposed to hide it in the ceiling tiles and forget it exists.
Right.
If it had a fan, that fan would eventually get clogged with dust, it would start to buzz, it would fail. By using a solid aluminum enclosure as a giant heat sink, it just runs silent and cool forever. No moving parts.
It's the ultimate set-it-and-forget-it piece of tech.
It's the invisible bridge. Next time you're in a huge auditorium or a lecture hall and you see this perfect, crisp 4K presentation on screen, don't look at the screen. Look up at the ceiling. I guarantee there's a little box just like this one hidden up there, quietly doing all the heavy lifting.
It really makes you appreciate the hidden infrastructure.
Yeah.
Which actually brings me to a final thought.
Go for it.
We're managing 4K pretty well with these clever compression tricks over good old copper wire, but 8K is right around the corner.
That is the big question, isn't it?
Are we just reaching the absolute physical limit of what twisted pair copper can handle? At what point do the laws of physics just say, nope, that's it, and we have to start ripping everything out for fiber optics? Something to think about.